Hello everyone, today we will be discussing what is executable linkable file format. So executable linkable file format or the ELF format is something that is understood by an operating system to run a C file. Okay, you have a C file and then when you compile that, I hope you know हम gcc followed by the file.c ऐसे हम करके फाइल को कंपाइल करते हैं, ठीक है. एंड इफ़ यू डोंट नो, इस जान लो कि इससे ऐसे होता है. एंड अगर हम इसको कोई स्पेसिफिक रीनेम नहीं करते तो हमारी एक ए डॉट आउट करके एक फ़ाइल बनती है. एंड व्हेन यू डू ./a.out तो आपकी सी फाइल रन हो जाती है. एंड दिस a.out, इफ़ यू नो ऑलरेडी नो दिस इज़ एन ELF फाइल. सो लेट्स सी ये होता कैसे है. I make a C file, for example, file.c. Suppose I am ready with my C file named file.c. So when I do gcc file.c and view the contents, so I have an a.out. I have an a.out here, and this is the ELF file. If you see the type of a.out by the file command, it will be, you can see it is a 64-bit ELF file. And suppose if I run that a.out, I can see my output. Welcome to kernel&coffee. So let's understand how all of this is happening. So when you have a C file, here we have our file.c. You can have any file name, okay? I hope you are getting this point. It initially converts to a .i file. Now what is a .i file? A .i file is a C file only, but it doesn't have the macros. Like we write #include stdio.h. So you won't see it like this, like a normal C file. It would be a different type of a C file. So let's see how it's gonna look. For example, I did gcc file.c. As of now, I'm not saving this file, so this will just output the contents. This is our .i file. You can see in the bottom of the file we have this int main only, but before this there is a shit ton of stuff. Like this is the expanded macros. There are no more macros here. It's just a C file, but slightly different one, of course. After this .i file, this .i file gets converted into a .s file. Now, what is a .s file? It is an assembly file. After getting converted into an assembly file, it gets converted into an object file. Can you guess what would be the type of object file? This is basically a binary file. It has machine code. Now this .o file gets converted into an ELF file. Now some of you might be thinking that when we have a .o file, which is a machine code, why don't we just run the machine code? Why do we need an ELF file? Because a machine code is understood by the machine, while an ELF file is understood by the OS. An ELF executable linkable file format, this is specifically to Linux. In MacBook, for example, you don't have an ELF. You have a mash-o file. Like that has its structure quite similar to ELF, but that is still different. So you cannot be having an ELF file in MacBook, of course. So let's see how do we get an assembly file as well as an object file and followed by an ELF file. Another thing, when you run an ELF, you get the output. To get an assembly file, we would be doing this, file.c. Now you have a file named file.s. Suppose I do cat file.c. Oh no, cat file.s. Yeah. So you have an assembly file for this. And to get an object file, we can do is gcc-c file.c. So there you have an object file. But if you do it, you won't be able to understand it because this is machine code. Like, I guess we cannot understand this. And now to get ELF file from this .o file, what we would be doing is gcc file.o -o my ELF. Now we have this my ELF. And just for your information, this a.out and my ELF would be same. For example, I do my ELF, I get the output, and now I do /a.out. You get the output. I hope you now understand how a C file is processed into an ELF file, and why do we need an ELF file? Because an operating system would understand an executable file, it won't understand machine code directly. So let us first understand what is the structure of an ELF file. Then we will be focusing on ELF header. So the structure of an ELF file comprises of basically 4 components. The first one is a ELF header. The second one are program headers. The third thing that we have are section headers. And the last thing that we have is data. So what are program headers? They are basically required by the OS loader. They are basically required by the OS loader. While section headers, if you see, they are not required by OS loader. They are not required by OS loader. Another thing that is the program headers, they are used at the runtime, while the section headers, they are used at the compile time. So we will be later looking onto the details of these things, but for today, our focus will be ELF header. So let us first see how does an ELF header look. I hope you remember these ELFs that we created. So this is the command for looking at the header. So we have copy pasted the header here, and first of all, what is magic number? This is for unique identification of an ELF. Like this, whether this is an ELF file or not an ELF file. The magic number actually helps us identify. Then we have class. It can be ELF 64 or 32. Okay. Then we have data, which is little endian, or it also can be big endian. As for version and ABI version, these are not that important. These are the default values that you are seeing here for version, ABI and ABI version. Then we have type, which is important, which is really important. The type is executable. We have 3 types of ELF files. One is executable, the second one is an object file or a relocatable file, and the third one is a shared library. So this that we have is an executable. So, and machine, when it comes to it tells us about that this ELF is for which machine. Like this is for ARch64. Then the version, again, that is not relevant. This is the general value. The next thing that you are seeing, the entry point address, this is quite important. This tells us about where to start the execution. This tells the OS loader where to start the execution. It tells the exact address. Then we have start of program headers and start of section headers. Like the ELF file that we have, how many bytes into the file we have the start of program headers or start of section headers. When it comes to flags, we have 0x0 here, which means there are no specific flags, but in very specific cases on some machines we need extra flags, so that's not relevant here much. Followed by this, we have the entry of size of this header, which is that we can see is 64 bytes. Like the ELF header, what is the size of this? I hope you know what is meant by 64 bytes. 1 byte is 8 bits, so I hope you can know that. Similarly, we have size of program headers and size of section headers, and then we have number of section headers, which is 30. But another thing that is missing here, which I guess I ignored while copy pasting, that is number of program headers. That we can see is 9. If I open the terminal, it's 9. So, and number of section headers we see is 30. Then we have section header string table index, that is 29. You know what is a section header string table? It is basically a section that contains name of all other sections. And this is quite important. The name of this section would be .shstrtab. Now these are the program headers and section headers that I've shown you. -s is for the section headers and -l is for program headers. Another important thing is that number of program headers will always be less than section headers. Now you might be thinking why? Because the number of program headers is like 9 and section headers is 30. So thanks for watching this video. If you liked what I shared, do like, share and subscribe, and comment whatever you liked or you didn't like about this video.